Hello everyone, my name is Mo, and in this video, we'll be going over my final capstone project in TensorFlow. So, what is TensorFlow? TensorFlow is a module developed by Google, which can do machine learning, or it's a learning module that develops neural network and can learn or create complex networks based on user input. So this module is not only readily available on Python, you can also get the same program in Java and C++ and many other programming languages. So in our case, we actually build a model which allows the user to upload an array of vegetable, and we train our model to learn what the vegetables are, and we test, and then after we test, we validate that data. So it's first training, validation, and then testing our data. So in our project, or a little bit more about why I chose to do this project. So our model can accept, as I said, images of vegetable. We can also train this same model to accept images of MRI scans or scans of brain tumors, which will help doctors or health professionals identify a brain tumor and the stage of brain tumor a person has automatically by automation using this module TensorFlow. So in our particular program, we use NumPy. We also use Pandas, and then we use Matplotlib library. So we use Matplotlib library a lot we mainly focus on Matplotlib library to plot out our training and training loss or accuracy data graph. So you will see that on the next slide. So this is my next slide. This slide is on design algorithm. So the model will be able to take in any picture and compress the size of that picture from 0 to 1. So what happens is how many ever pixel it is, it only compresses it to 0 to 1 pixels, and then from that it actually takes in the feature detection. The model uses conventional layers to detect features in the images like edges and shapes. So what our model does, it converts it uses the Keras library within TensorFlow to actually convert the images that we upload, whether it be 3D images to 2D, or if we do upload 2D images, it becomes a 1D image. So it's much easier for our model to process. And we also set the parameters, or we also set how much the image height and image width, so that all images are fed into our model on the same what can you say on the same size. So it's much more accurate. Third, we drop 20% of neurons while we are training our model, just because we randomly want to drop anywhere between 30 to 20% of neurons while training, so that your model does not end up memorizing the particular image that you're uploading into it. So, for example, if you're uploading a picture of a banana or an apple, you don't want the model to learn 100% of its features, like shapes and edges, or then that's going to be your model memorizing those pictures. That's not what you really want in our case. You want it to learn from what we upload. And then finally, based on your training and validating, you test it by uploading new pictures that you have not uploaded before. So to recap, we have testing, training. Training would be to upload pictures into the model, and you tell what pictures it is. So if you're uploading an apple, and you tell the model it is apple. With validation, you upload that apple again, but you don't tell it that it is an apple. You let the model verify itself or validate itself on what type of image it is, and then for testing, you upload an array of new pictures that you have not uploaded before, nor you name those pictures that you're uploading, so that your model can generate an answer for you, and based on that answer, you get an accuracy or you get your accuracy or loss percentage. So this is my software development lifecycle implementation. So before I started I wanted something that will help workers in the medical field. So I started to develop this or plan for this particular project. And then for design, I want the project to be able to to train that model, validate that model, and then test the data. Implementation would be to use Tensor Flow and Cures to train the model. And we also have a Streamlit library, which the user will be able to upload a picture of their own. So any pictures that they choose they want to upload, they can do so in this model. And this model should be able to identify what type of picture the user uploaded with the accuracy rating. And then finally, deployment. So again, we're going to use Streamlit library to deploy from via the user interface. And you can also deploy this project in GitHub for other users to download. Second to last slide, I used Jira to plan for this project. So Jira can help you plan for this project by allowing you to upload any necessary tasks that needs to be done. So you can simply input any new tasks, and it will be synchronized in order. So for example, if you need to train or gather data of pictures or array of pictures for this model, you can set that as a task, and you can label it in process when you're doing it, and then you can label that particular task as done when you're completed with that task. This is our final slide of Figma. So this is what our classification model should look like. It should have a bar where we can upload images. So you can either drag and drop, or you can type the file name in the same directory, and that image will be uploaded to your model, and your model will be able to identify if it is a fruit. So and if it is a fruit, what type of fruit it is with the accuracy percentage. So if it is 100% sure or 99.99% sure that it is an apple, it's going to say it's apple, or it might make errors, but this is the Figma of how the Streamlit library or the user interface should look like. Thank you for watching, guys. So I'm not sure if I'm supposed to do a demo here, but I did not do a demo here. If you want to see the demo, you can check out my YouTube channel. But yeah, thank you for watching. Have a good night.